So if you're ready to hook up to this tutorial for the personal training, I would say you should just follow the link down below this training and join our Ekidel Mentorship Class. Okay, so thank you. So I've already done the theory about when to add your wind load, right?
Yes.
Oh, okay. So like I said again, you only add your wind load when your structure is more than 10 meters high. So looking at this right
Yes.
now, this is 12.6 meters high. So this building right now requires us to add our wind load effect. So right now to add a wind load, first of all, go to that loading and combinations. Let us activate that wind load. Okay, then go to loading generator. Okay, then go to horizontal loading combinations. Horizontal load combinations, the other one. And check that place called wind load. Check that wind load. Okay, and then click on OK. So once you check that right now, it will take all the design codes based on wind load into this model. Then say OK. Final OK. Okay. Then now click on the place called wind and story loads. Okay, now on this place right now, we'll now click on the place called wind load calculator. Okay, now on this place right now, you can see that you have places to put your options, wind values. So the first option there is basic wind speed, which is measured in m/x, which is meter per seconds. So you have to input your wind speed of that particular area where this building is to be located. So for example, well, actually you are meant to get this value from your weather scientist, or you can also check on Google and get the highest wind speed that have ever occurred on that particular area. So what you just do is to type that site location on Google, and Google will give you the highest wind speed that have occurred on that particular area, or that particular location. So the highest wind speed ever that have occurred in the world, that is in Jamaica. That's 69.5 meter per seconds. So, but we cannot use that highest wind speed here. So since let us assume that okay, just open Google and check Google highest wind speed ever occurred in South Africa, since your country is South Africa. So check, let's see. Can you hear me? Are you there? Okay, yeah. Google, let's see. Okay, highest wind speed ever occurred in South Africa, or recorded in Kia, ever recorded in South Africa. Okay, let's see. Okay, so this one right now called 1984. That is 8186, which is very very high. The reason why this occurred was because if you check this date 1984, during this period, there is no the everywhere seems to be very plain. There is no much tall buildings around the cities or area. But now we now have tall buildings almost every area of every cities. So with that buildings around the cities, it will not allow wind to have effect directly on most of the structures. But like we always take our record 40 years back. So if we look at this one 1984, this is already more than 40 years um back backward. So again, we also looking down, okay, that's a storm. That is storm. So looking at this one, and also this is measured in kilometer per hour, although so we can convert that, although that's very high for this type of building, it's very high for us to use that. So but let's just use a guessed value. We can use 50 or 45. Like here in my place here in my city here, our own here is 45. Average wind speed here is 45. So we can use 50 in South Africa if that place experience. But actually, you're meant to get this load effect, wind speed effect from your weather scientist. So let's just use 45. Let's see that 45 45 meter per seconds. Hello, put in the value 45. Can you hear me? Yeah, 45, that's fine. Then this place right now called minimum wind speed pressure. This one we just put a value that is more than 0. So you can put 0.5 there. Okay, then this one that is called primary wind angle. This one we leave it at default because no one knows the angle that the wind comes from. So in that course, we don't use to put any value there. We just leave it at 0. Then this place right now, which is the terrain and surrounding. On this terrain and surrounding, you can see the place called he height. Sorry. Now that he height simply means if you have a place like,
Yes, I can see.
yeah, that he height. What he height simply from this diagram right now, you can see the diagram on this place here, this diagram here. Can you hear me?
Yeah.
Yeah, on this diagram showing here, you can see that wind direction hitting the building. So the heel
Yes.
here simply means if you have, let me say, since this is a 4-story building, if you have something like a 3-story building around the place where this building is to be sited, or 2-story building, so that building now acts like a heel height. Simply means that when a wind blows right now, it will blow on that 2-story building and it will now cause something like a refraction, or let me say diversion, before it now hits your building. I don't know if you get me.
Yeah.
Or let me say you have something like trees around the place also, which is, let me say, and the tree height is around, let me say, the height of the tree is up to 2-story building, some of them 1-story building, and some 3-story building. And your building is 4-story building. That shows that when the wind effect comes, it will not hit directly on your building. First of all, it will first of all hit on those trees, or let me say obstacle, before it will not hit on your
Yeah.
building. So for it to hit on that obstacle, those obstacle, which is the trees, they have tried to break that effect of that wind a bit, to at least, let me say, 30% or 40%, before it will now hit on your building. So with that, those trees have also helped to like break that wind speed coming to hit a building. So let's assume now that the height of the hill height, or the height of the building around that place, let's say is sorry, I'm not seeing your screen. Okay, I'm not seeing your screen again. Okay, let's say is up to 2-story building, which is 2 stories should be around 9 meters. So let's just put that. Okay, let's put the 9 meters. The same thing for x. Now that x right now, the x simply means distance from that obstacle or the tree to your building. I don't know if you get me. Let me say the distance
Yeah.
is around the roadside, and your building is inside the compound. So you have to take that distance. So, but all this terrain area, we just try to assume it. So since the height is 9 meters, we can use Pythagoras rules to just get the length. So let's just assume that the length is around 4 meters. Using the right angle triangle formula, let's just say is 4 meters, 459 or that. But so let's use 4 meters on the distance from the obstacle or tree to a building. Yeah. Then the LD, which is you're seeing there, simply means actual length of the downward slope in the wind direction. This place right now, we just leave it as default as 100. These two values, this LD and LU, we leave it as default as 100 and then that 150. Then the place showing hill type, click on that option, that hill type option. Now this hill type right now, you can see cliff and what's that? I'm not seeing it very well. The first option there is what?
Cliffs and escarpment.
And the second one is hill and ridges.
Cliffs
You
and
just you just leave that first one cliff. Leave the first one there. Just
okay.
choose the first one cliff, and the second one, which is upwind and downwind, leave it as an upwind. Leave this one as upwind. Then we leave these two place also as one as it is. Then click on the place category. So basically, your what you should consider first is a hill height and that hill and that obstacle distance. Then on this place right now, categories. This categories simply shows you where your building is located. Let me say that I think capital of South Africa is this place, Johannesburg. Yeah. So let me say someone is building a 10-story building at let me say 4-story building, Johannesburg, and you and I know that Johannesburg, they have up to 16-story building, 8-story building, right? All right.
Yes.
Yeah, so they have
Yes.
buildings around. So if you're going to site your own 4-story building, your own 4-story building will be like a baby around those 10-story, 8-story. So with that right now, the wind effect will not be much on your building because they already have existing buildings like a city. You understand? But if
Yes.
you want to go and build your building, or let me say around a forest, like a village, rural area, you see that that place they have, let me say, bungalow and 1-story and all that, and then bushes and all that. So if you can build your 4-story building, there is a tendency that the wind effect will be much on your building because around that terrain there is no tall buildings up to that your own standard. So you have to pick your option here. We always pick a worst condition if you don't know the place where to be built. But for you to be designing, that means you should be able to know this building location. So let's assume that this building is to be sited, um, let me say, in a rural area. So we have to pick let us begin to take the option. The category 0 simply means sea and coastal area. So when you're building on a sea area, there is what they call sea wind. So the wind of that area should be very, very high. Then on this category 1, which is flat area with reliable vegetation without this, but I basically used to pick category 3. Category 3. Yeah, that's what I used to pick. So you just have to choose those options. Okay, then click on OK. Then on this place right now, building category, which is up here, if you check that option, you see other type of buildings like steel and all that. So what we're designing is for a reinforced concrete. So you just pick that option, reinforced concrete. If you're doing for steel, you choose for steel or for composite structure. Okay. So right now, once you're done with this, then if you check below here, you see that wind code. So if you don't have your wind code already, you just go there and choose. So just click that option. We already have our wind code, so leave it since we are using this code, Euro code. So just leave it that way, and then click on apply. Okay, and then click on OK. Okay, that's fine. And then once you're done, click on parameters. Parameters, and then okay, parameters. If it was in 20, okay, that's fine. But if it was in 2021, that place where you pick your wind load, you won't see the option there. You will like see it here. But since we already picked that option there, which is the wind load code, there is no need picking it here again. but in the newer version of Prota, you'll be seeing that load here and not that place. So just click on OK on this one. Okay, yeah, and then click on close. Then run the building analysis. Now, if you run it now, you see that all the columns that passed before without the load, without the wind load, they will all fail on this one because we have applied wind load. There we go. Okay, run it now. Okay, so let's see. Okay, so let us see the design status. Okay, so you can see that your columns have all failed because the columns are very small. So when you apply wind load on buildings, you should be expecting that your column sizes will going to increase, and also the beams will also increase because the wind load effect will now affect the columns. So you now begin to perform interactive design to check if the columns sizes are adequate. If they are not adequate, you now go and increase the size of the columns. I don't know if you get me.
Yes, I do.
Okay, so that is the way to apply wind load. So by knowing this right now, we can now go ahead I don't know if you have time towards the evening for us to begin the 8-story building design. So I would like you to check these ones after when you have time. Check the columns and see how the wind load effects have now affected the columns bars reinforcement. Then you can choose to now increase it and all that. Then I will try and send the 8-story building so that we can use that to perform for for the next design. Okay, then what again? Okay, we say we'll enter steel this same week, this steel design. Okay, that's fine. So I will send the 8-story first. So that's how to add a wind load to your structure. Any questions so far?
No, the stairs, we are going to do it later.
Which one is that?
Do we do the staircase as part of this design that we're doing now, or we do it separate?
Which of them? Sorry.
The staircase,
Staircase?
like now in this structure, we are not doing the staircase.
No, 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 no. We don't normally model staircase here. Most people used to do it just to be fanciful. Most people, if you check most videos on YouTube, they just model it just to make their model fanciful. But it's not well. If even in manual design, we don't design staircase as we are designing like the building entirely. We used to design staircase separately on its own. That's why we always keep that staircase hall area as a void, so that we can design it separately and then just come and fix it there during construction. So we do staircase design separate, not alongside with the building.
Okay.
Okay, yeah. And also Prota doesn't do, although they have not yet done their staircase very, very well. But although there is one software which I used to use for my staircase design and also analysis.
Which one have you been using?
Yeah, I will show you that one. Casey Soft, actually, Casey Soft. We used to do staircase
Oh,
design
okay.
and then analysis here. So I will show you that
Okay.
too. Yeah. Okay. So I would like you to check the columns later to see how the wind load have affected it.
Okay.
Okay. So will you have chance this evening? Or
I think
how is your power
electricity is
line?
going a bit earlier today, but it's coming back at, I think it's going to come back at 10 o'clock your time.
Okay, 10 o'clock. Okay, we can just have a 1 hour session. Maybe just model it because that 8-story reading will carry flat slab, we also carry rib slab, we also carry cantilever curve. curved slab, and also curved beam, and then inclined column. So let me show you about those ones too.
Okay, we can start at 10 o'clock your time. That's
Yeah,
when electricity is
okay, we
on.
can just do a few model, just model for the first story first. That's all we can do from there. Okay, now, so that will be
It's
nice.
just that here the office electricity is going now in 30 minutes time. So otherwise you're going to send it to me, then I'll just
Oh,
start to have
okay.
a look at it and see if I can start modeling it.
Oh, okay, okay, okay. That's fine. No problem. Okay, yeah. I will send you the plan now. Yeah.
Okay.
Okay, now. So later we'll see. Bye.
All right.
Okay, yeah. So if you're ready to hook up to this tutorial for the personal training, I would say you should just follow the link down below this training and join our Ekidel Mentorship class. Okay, so thank you, and then move on to the next.